Okay, that was step one. Step two is to calculate how much volume is occupied by this dinosaur body here. And the way to do that is to submerge it in water and find out how much water it's displaced, and then you can calculate what the volume of this model is. Then if you know what the actual length of an Ankylosaurus skeleton is, you can scale up your volume so that you get the true volume of a real Ankylosaurus. And if you know how much animals weigh per unit of volume in general, you can figure out how much a real Ankylosaurus weighed. So, I got our a container of water here, and I've filled it up ahead of time to, and I've tried this out to make sure that when I submerge the Ankylosaurus in there, it will be able to completely cover it. You might want a little towel around while you're doing this. So now I've submerged the Ankylosaurus in the water. And the water level went up. So I'm going to take a little piece of tape. I'm going to mark exactly where that water level is. This is, not high tech. I'm going to, and this is really, this is a step you really want to be as accurate as possible, because let's face it that it's going to be hard to, we're going to have to make some eyeball estimates here, and so as close as you can get, because we're going to be dealing with small volumes of water, as close as you can get, that will allow your answer to be more accurate. And if you're off just a little bit, it's going to multiply and give you an answer that's pretty inaccurate. All right. So now I've marked where the water level is with the dinosaur in there. I'm going to take the Ankylosaurus out, and of course the water level dropped down, and I'm going to find out how much water I have to put back in here in order to bring it back up to the level it was. And I do that by using these utensils for adding, for working in the kitchen. And one thing I'm going to do very carefully is, okay, I've measured a 1/4 cup of water. I poured this in. Check. Now the water level still isn't high enough. Now, it's getting close though, and I don't want to put in another 1/4 cup because I'll probably overshoot. So I'll take my tablespoon, add a tablespoon of water. Yeah, not quite there yet. That looks pretty close. So what I've done is I've added a 1/4 cup of water and 2 tablespoons. Well, how do I work with that? Really what we want to do is get our measurement in something that we can work with, and in this case it's cubic centimeters is one way to represent volume. Well, you can go on the internet, very conveniently find out, well, how much is a tablespoon? How much does a tablespoon contain? And you'll find that a tablespoon is about 15 milliliters, or 15 cc's, or cubic centimeters, of volume. So we put in 2 tablespoons, so that means 15 plus 15, we put in 30 cc's, 30 milliliters, and we put in a 1/4 cup. You can also find out that a cup in volume is about 240 milliliters, or cubic centimeters. So a 1/4 cup is a 1/4 of 240, and so that's 60. So we put in 30 cc's by tablespoon and 60 cc's by measuring cup, and so we've seen that our dinosaur model displaced about 90 cc's of water. All right, that gives us a volume estimate.